Everyone, welcome to the problem set 3 of the lecture series Signals and Systems. So in this video, we'll be solving some questions based on the topic Fourier series. So let's get started. First question. A continuous time periodic signal x of t is real valued and has a fundamental period t equal to 8. The non-zero Fourier series coefficient for x of t are a1 equal to a minus 1 equal to 2 and a3 equal to a minus 3 conjugate equal to 4j. Express x of t in the form x of t is equal to summation k equal to 0 to infinity ak cos omega kt plus phi k. So we saw the Fourier series representation in form of complex exponentials, which is given by minus infinity to infinity ak e power j k omega naught t. And we also saw for real x of t, we can write it as a0 plus summation k equal to minus infinity to infinity sum bk cos k omega naught t plus ck sin k omega naught t. So we can again rewrite this in the form of a single cosine with a phase term. So let me go through the derivation for that. So if we assume bk is sum ak cos phi k and ck is minus ak sin phi k. So this is nothing but mapping from bk comma ck to ak comma phi k. And how this mapping is defined? If you take the square of both, these both are real coefficients, then you will have ak square cos square phi k plus ak square sin square phi k. This is nothing but ak square into cos square plus sin square, which is equal to ak square. So we can write ak is nothing but root of bk square plus ck square. And if we divide, let's say ck by bk, then we get ak is cancelled, minus sin phi k by cos phi k, which is nothing but minus tan phi k. So phi k is nothing but tan inverse of minus ck by bk. So these two mappings we have. Now if we substitute bk and ck in this equation, we have a0 plus summation k equal to minus infinity to, this is from 0 to infinity, 1 to infinity, correct? So 0 to infinity or 1 to infinity, bk is ak cos phi k into cos k omega naught t minus ak sin phi k sin k omega naught t. So again, if we take ak common out, we have the formula for cos a plus b, which is nothing but cos a cos b minus sin a sin b. So this implies that x of t is a naught plus summation k equal to 1 to infinity ak cos of k omega naught t plus phi k. So this k omega naught, if we replace it by omega k and we absorb a naught also into this equation, then we can rewrite this as k equal to 0 to infinity ak cos omega kt plus phi k. So this is also another way to represent the Fourier series. So for observing a naught into ak, what we have done, a0 we have made it a0 and phi 0 we have made it 0. So now let us go for the following problem. So the time fundamental period is given as t equal to 8, which means omega naught is 2 pi by t, which is 2 pi by 8 is equal to pi by 4. And they have given x of t is real valued, okay, and the non-zero Fourier series coefficient for x of t are A1 equal to A minus 1 equal to 2 and A3 equal to A minus 3 conjugate equal to 4j. So we can proceed the usual way, and finally let's see how we are bringing to this form. So usual way, we have x of t is summation k equal to minus infinity to infinity ak e power jk omega naught is pi by 4. So pi by 4 into t. Now we know a1 is 2, a minus 1 is 2, a3 is 4j, and a minus 3 is nothing but minus 4j because of the conjugate. So x of t is 2 e power jk pi by 4t plus 2 e power minus jk pi by 4t. Sorry, k is 1, right? K is 1 and minus 1 here. So it's just pi by 4. Pi by 4t plus 4j e power j 3 pi by 4t minus 4j e power j and 3 pi by minus 3 pi by 4t. So this one there is a plus sign, so we can directly bring it to the cos form. But this one there is no direct plus sign, it will come in the sine form. But we know that sine and cos are related by just 90-degree phase difference. So we can either convert first into sine and then convert to cosine, or we can directly modify this and write it. So let me show you. So this is 4 into e power j pi by 4t plus e power minus j pi by 4t by 2, and plus j we can write it as e power j pi by 4 pi by 2, right? And this is e power j 3 pi by 4t minus 4. Minus j we can write it as e power minus j pi by 2 and e power j minus j 3 pi by 4t. So this is 4 cos pi by 4t plus 8 into e power j 3 pi by 4t plus pi by 2 plus e power minus j 3 pi by 4t plus pi by 2 divided by 2. So this is in the cosine form. So 4 cos pi by 4t plus 8 cos 3 pi by 4t plus pi by 2. So this is the form they have asked, right? So in the form of cos omega kt plus phi k. So that is what we have got. So let us move on to the next question. Suppose we are given the following information about a signal x of t. Okay, what is the information? X of t is real and odd. Okay, x of t is periodic with period t equal to 2 and has Fourier series coefficients, Fourier coefficient ak, and ak is equal to 0 for mod k greater than 1 and 1 by 2 integral 0 to 2 mod x of t whole square dt is equal to 1. So let us go ahead and see what each information conveys about the Fourier series coefficient. And we have asked to specify 2 different signals that satisfy these conditions. Okay, so first one says x of t is real, which means x of t is equal to x conjugate of t. But this also implies that ak is equal to a star minus k, right? And x of t is odd. This implies that x of t is equal to minus x of t. This also implies that ak is equal to minus a minus k. So we already saw this in the properties of the Fourier series. Anyway, I'm doing it once again. So we have ak equal to a minus k conjugate, which is nothing but minus a k conjugate. So ak's are purely imaginary. And the other thing is ak is also odd. Or odd. So when AKs are odd, what does it mean? If we substitute A0 is equal to minus A0, which is A0 itself, minus A0. So 2A0 is equal to 0. We get A0 is equal to 0. Okay. So in the second information, what they are saying, x of t is period with period t equal to 2. So t is equal to 2, which implies omega naught is equal to 2 pi by t, which is equal to 2 pi by 2, which is nothing but pi. In the third, they are saying ak is equal to 0 for mod k greater than 1. So there are only three coefficients, a0, a minus 1, a1 or non-zero. But we already got that a0 is 0 because of ak is being odd. So a0 is 0 from 1, hence only a minus 1 and a1 are non-zero. So what does the next information say? So 1 by t integral 0 to 2 x of t mod whole square dt is equal to 1. So this is nothing but the power, right? Average power of x of t. But using Parseval's identity, we know integral 1 by t naught over t naught mod x of t whole square dt is equal to the summation of the powers in each harmonic components. So now this 1 by 2 integral 0 to 2 mod x of t whole square dt is nothing but a minus 1 mod square plus a1 mod square, and this is being given as equal to 1, right? Okay, let me take a new page. So we know a1s are purely imaginary, right? a1 is equal to minus ak, and we also have a minus 1 is equal to, because it is odd, a1 is equal to minus a minus 1. So mod a1 is equal to mod a minus 1. So using this will get us 2 times mod a1 square is equal to 1. So mod a1 square is 1 by 2. So mod a1 itself is plus or minus, or we'll just have 1 by root 2, right? So since a1 is purely imaginary, a1 can be plus or minus j by root 2. So we'll go with case 1. They're asking for two signals. So these will give correspondingly the two signals. So a1 equal to j by root 2. So in this case, what will be a minus 1? Since it is on, it will be minus j by root 2. So then we can find x of t by substituting it in the Fourier series coefficients. So x of t is summation k equal to minus infinity to infinity ak e power jk omega naught t, and this is equal to minus j by root 2 e power minus j omega naught t plus j by root 2 e power j omega naught t, and omega naught is pi, correct? So we can replace here as pi and pi. So here we can actually take j by root 2 outside, and we have e power j pi t minus e power minus j pi t, and if we divide and multiply by 2j, this will get as a sine term. So this will give minus root 2 sine pi t. So in the other case, we have a1 equal to minus j by root 2. So a minus 1 is plus j by root 2. So x of t will be j by root 2 e power minus j pi t minus j by root 2 e power j pi t. So x of t is j by root 2 we can take common out, or minus j by root 2 we can take common out, and then we have j pi t minus e power minus j pi t, and multiplying and dividing by 2j. We have 2 by root 2, and this minus 1 into minus 1 will become plus. So we have root 2 sine j pi t, or sine pi t, sorry. So these are the two signals. Therefore, the two signals are root 2 sine pi t and minus root 2 sine pi t. So this way you should be able to get x of t from the given information. So this is a very common question, and it is very interesting as well. Moving on to the next question. Consider a continuous time LTI system whose frequency response is h of j omega is equal to sine 4 omega by omega if the input to the system is periodic signal with period t equal to 8. So this is the periodic signal. Determine the corresponding system output y of t. Okay. So x of t is given by this. Let us draw x of t. So x of t, we have 0 to 4 and 4 to 8. Since it is periodic, it will be repeating. So it is 1 here and minus 1 here. It's going to repeat. Right? So 1 and minus 1. This is x of t. And the time period is going to be 8. So what is omega naught going to be? 2 pi by 8, which is nothing but pi by 4. Right? So if you are able to represent x of t in terms of the Fourier series coefficient, we will get some ak e power j k pi by 4t. And passing through the LTI system with this response, we will actually get an output such that these coefficients will only change and others will be remaining same. We will get ak h of jk omega naught. So there is this factor being multiplied. We saw it in the previous lecture. And this remains same. And omega naught is nothing but pi by 4. Okay. So let us now go ahead and find this term from this expression. So h of j omega is given as sine 4 omega by omega. And we need to find hk pi by 4, which is nothing but sine of, instead of omega, we have to substitute it with k pi by 4. So k pi by 4 into 4 will be just k pi divided by k pi by 4. So then we can substitute this here. But sine k pi, we know it is going to be equal to 0 for all case, right? Sine k pi is equal to 0 for k equal to 0 plus minus 1 plus minus 2, all integers. But k is also going to be 0 for k equal to 0. So at 0, we need to find it through limit. But in all other case, this expression is going to be 0 because the numerator is 0 and denominator is finite. So h of jk pi by 4 is equal to 0 for k equal to plus minus 1 plus minus 2 and so on. So what about sine limit k tends to 0 sine k pi by 4? So we can find this from the limits. So we know sine x by x limit x tends to 0 is going to be equal to 1. So this is going to be equal to 4 because sine k pi by k pi will be 1 and this 4 will go to the numerator. So this is equal to 4 for k equal to 0. So only the DC term in the Fourier series is going to remain. So we'll get 4a0. But what about a0 from x of t? Since it has a same number of positive and negative, its average is going to be 0. So a0 is nothing but 1 by t naught, which is 8. 1 by 8 integral 0 to 8 x of t dt. And this is going to be equal to 0 because for 4 units of time it is 1 and other 4 units it is minus 1. So they will cancel. So this is also going to be equal to 0. So y of t is going to be equal to 0 itself. So in this case, you needn't derive all the coefficients for x of t. It is just sufficient if you observe the fact that h of jk omega naught is going to be 0 for all other coefficients except dc, and at dc x of t itself is going to be 0. So we get y of t as 0. So moving on to the next question. Consider a causal continuous time LTI system whose input x of t and output y of t are related by the following differential equation. So d by dt y of t plus 4y of t is equal to x of t. And find the Fourier series representation of the output y of t for x of t is equal to cos 2 pi t. Okay, so we have first x of t is equal to cos 2 pi t. So this is nothing but e power j half into e power j 2 pi t plus half into e power minus j 2 pi t. Right? Because its time period is going to be equal to 1 and its omega naught is equal to 2 pi and only a1 and a minus 1 are non-zero. Right? Now we can find h of j omega. We need to find h of jk omega naught from this differential equation. So we will just assume x of t is e power st. So y of t will be nothing but, since it is an LTI system, it will be some h of s into e power st. We know this. Now let us substitute this in this equation. So dy of t by dt plus 4y of t is equal to x of t. So this is d by dt h of s e power st plus 4h of s e power st is equal to e power st. So this differentiation will give us s into h of s e power st. Since h of s is not depending on t, only this term is depending, we will get s here. So plus 4h of s e power st is equal to e power st. So we can cancel e power st. So in here h of s is common. H of s into s plus 4 is equal to 1. This implies that h of s is equal to 1 by s plus 4. Now, we need to find h of jk omega naught, and omega naught is 2 pi. So this is nothing but 1 by jk 2 pi plus 4. And in specific, we want k equal to 1 and k equal to minus 1. So h of j 2 pi is equal to 1 by 4 plus j 2 pi, and h of minus j 2 pi is equal to 1 by 4 minus j 2 pi. And now we can directly find y of t. So y of t is nothing but this coefficient half e power j 2 pi t into h of j 2 pi plus half e power minus j 2 pi t into h of minus j 2 pi. And this is going to be 1 by 2 into 4 plus j 2 pi e power j 2 pi t plus 1 by 2 into 4 minus j 2 pi e power minus j 2 pi t. And this is what they have asked us to find, the Fourier series representation of the output y of t, which is what we have found. Okay, now let us solve some previous year questions from GATE. So the first question, choose the function f of t from minus infinity less than t less than infinity for which a Fourier series cannot be found. So let us go through the options one by one. 3 sin 25t and 4 cos 20t plus 3 plus 2 sin 710t and exponential of minus mod t sin 25t, and the last option is a constant one. So we know that Fourier series exists for periodic signals. And we have other constraints, but all these signals satisfy those constraints, like the Dirichlet conditions. All these 4 signals satisfy those. So let only thing that can differ is if they are periodic or not. You can see that 3 sine 25t is periodic. If we just substitute 3 sine 25 into t plus t, we get 3 sine 25t plus 25t. So if 25t is equal to 2 pi, then it is periodic. So t will be equal to 2 pi by 25. Right? And hence its omega naught is 25. So it is periodic. So this is there, the Fourier series exists for this. What about the B option? So 4 cos 20t plus 3 plus 2 sine 710t. So when 2 cosine series or sine are added and they are of different time periods, so individually they may be periodic, right? Cos 20t plus 3 is periodic with omega naught equal to 20, and sine 710t is periodic with omega naught 710. But when they are added together, for them to be periodic, their time period ratio should be rational. So t1 by t2 should be a rational number. So only if it is rational, we can find some term where both can be periodic. For example, if you take cos 2 pi t and sine 6 pi t. So this is periodic with t naught equal to 1, and this is periodic with t naught equal to, or we can say pi by 3, t naught equal to 6. Then you can see that, so this cos 2 pi t is periodic for t equal to 1, 2, 3, 4, 5, 6 and so on. And the sine 2 pi by 3t is periodic for t equal to 6, 12, 18 and so on. So we can find some common terms between them. So at 6 we can say both are periodic. So when we can say we can find some common terms, then only we can say the entire expression is periodic. So for this to be possible, t1 by t2 ratio should be rational number. So here we can check directly if they are rational. So t1 is nothing but 2 pi by 20 and t2 is 2 pi by 710. So t1 by t2 is 2 pi by 20 by 2 pi by 710, which is nothing but 710 by 20, and this is rational. So x of t is periodic. Hence Fourier series exists. Suppose if it was 2 pi t and this was 20t, then you can see the ratio will involve pi. If it is pi, then it becomes irrational. Then this entire expression will not be periodic. Okay? This just for your understanding. Okay, so the B option also Fourier series exists. C, we have a exponentially decaying function. So exponential of minus mod t sine 25t. So this will actually go like this, right? This is sine, but since it is exponentially decaying, we'll have something like this. And on both sides, it is exponentially decaying. So this is not going to be periodic. This is not periodic. Hence, Fourier series does not exist. So let's check out the last one also. For D, for a constant, we actually cannot define a time period. But can Fourier series exist? Yes, right? Such that A naught is only 1 and AKs, all other AKs are 0 or K not equal to 0. So the Fourier series still exists, right? Even though the time period is not defined. Why this is so? Because if it is a constant, any time period will apply. So let's say the time period is 1 if we take T not equal to 1. And if we repeat it, it will still work. If T not equal to 2, and if we take and repeat this, it is still going to work. So the time period is not going to be defined, but still it is like a periodic signal. So hence Fourier series exists for this. And this is the Fourier series. And T naught can be anything. It doesn't matter. So the question is, which of these is Fourier series cannot be found? So the correct option is C. Moving on. The Fourier series of a real periodic function has only, they are given some options. P is cosine terms if it is even, sine terms if it is even, cosine terms if it is odd, and sine terms if it is odd. And they are asking which of the following statements are correct. So they have given real periodic. So x of t is a0 plus summation k equal to 1 to infinity bn cos k omega naught t plus cn sin k omega naught t. So this is the expression for real periodic function. And they're asking what happens if it is even, what happens, and if it is odd, what happens. So let us see if it is even, what happens. Even. So x of t is equal to x of minus t. So x of t is nothing but a naught plus summation k equal to 1 to infinity bn cos k omega naught t plus cn sin k omega naught t. This is equal to x of minus t, a naught remains same. Cos of minus t is cos itself. So cos k omega naught t, and sin of minus t is going to be minus sin t. So this is minus cn sin k omega naught t. And both sides a naught is common and this cosine terms are common. Those will cancel. So we are left with k equal to 1 to infinity cn sin k omega naught t is equal to minus summation k equal to 1 to infinity cn sin k omega naught t. And if we bring it to the other side, k equal to 1 to infinity 2 cn sin k omega naught t equal to 0. So this implies that divide by 2 on both sides, the sine terms are going to vanish. So as only cosine terms if it is even. So if it is even, the sine terms are going to vanish and only cosine terms are present. So what happens if it is odd? So x of t is equal to x of minus t. So a naught plus summation k equal to 1 to infinity bn cos k omega naught t plus cn sin k omega naught t is equal to a naught plus summation k equal to 1 to infinity, and it's minus sign. So minus a naught minus bn cos k omega naught t, right? And minus cn sin k omega naught t. So a naught term is not going to cancel because this side it's plus and minus, but cn is plus on both sides. So minus into minus is plus. So cn terms, sine terms are going to cancel. And if we bring the a naught to the other side, we have 2 a naught plus summation k equal to 1 to infinity bn 2 bn cos k omega naught t equal to 0. And if we divide by 2, we have bn cos k omega naught t equal to 0. So the cosine terms are vanished. So cosine terms vanish, only sine terms are left. So here sine terms vanish, only cosine are left. So what is when it is odd? Only sine terms are left. So P and S are correct statements. The option is A. Moving on. Let x of t be a periodic function with period t equal to 10. The Fourier series coefficient for this series are denoted by ak. That is x of t is equal to summation k equal to minus infinity to infinity ak e power jk 2 pi by tt. The same function x of t can also be considered as periodic function with period t prime equal to 40. Yes, that is possible, right? Then let bk be the Fourier series coefficient when period is taken as t prime. If summation k equal to minus infinity to infinity mod ak is equal to 16, then summation k equal to minus infinity to infinity mod bk is equal to. Okay. So this is a very interesting question. So we have x of t is equal to summation k equal to minus infinity to infinity ak e power jk 2 pi by t into t. Now if we consider t prime equal to 40, so here it is 10. If we consider it to be 40, then we have new Fourier series coefficient bk. So which is nothing but jk 2 pi by 40 t, right? So if we are somehow able to relate ak to bk, then we can find this power term, right? And this is not even the power terms, right? It's just the modulus of the Fourier series coefficient. So we cannot use Parseval's theorem here. So we have to go with the relation between ak and bk. So let us see. Let us just try to manipulate this. So what is happening, right? So x of t summation k equal to minus infinity to infinity ak e power jk 2 pi by 10 t. So if we try to expand this, what we are going to get? X of t equal to summation k equal to minus infinity to infinity bk e power jk 2 pi by 40 t. And if you see, for every k equal to 4n, this is going to represent same as this, right? If I replace k equal to 4n, then summation 4n equal to some minus infinity to infinity bk, and k is 4n e power j 4n 2 pi by 40 t. So this is nothing but summation 4n equal to minus infinity to infinity b 4n e power j n pi by 10 2 pi by 10 t. Now if you see this and this are same, right? So we can say that b4n or b4k is equal to ak, right? And what about b4k plus 1, b4k plus 2 and b4k plus 3? So what happens to them? So they are going to be equal to 0. So then only we can actually say this is equal to this, right? So if we assume these values for bk, then it is going to represent this one is going to be equal. So it is a convenient representation. So in that case, then what happens? Summation k equal to minus infinity to infinity mod bk is nothing but, since these are all going to be equal to 0, summation, we can say k equal to minus infinity to infinity mod b4k, right? And we need to modify this to 4. So I'll assume n 4n 4k, right? Or 4n equal to, this is going to be equal to k equal to minus infinity to infinity mod ak, and this is equal to 16. So this absolute sum of the absolute terms of bk is going to be equal to sum of absolute terms of ak. So the correct answer is option 16, option C, which is 16. So when you're actually assuming a higher period, you can actually do this. You can directly find the Fourier series coefficient from the previous ones. Okay, you just put other coefficient to 0 and just assume the integer number which is a proper multiple of the period, and you can assign them as the Fourier series coefficients of the previous one. So using this, you can just change the period also conveniently. Okay, moving on to the next question. A periodic signal x of t has a trigonometric Fourier series expansion. X of t is equal to a0 plus summation n equal to 1 to infinity an cos n omega naught t plus bn sin n omega naught t. Okay. If x of t is equal to minus x of minus t is equal to minus x of t minus pi by omega naught, we can conclude that an are 0 for all n and bn are 0 for n even, an are 0 for all n and bn are 0 for n odd, an are 0 for n even and bn are 0 for n odd, or an are 0 for n odd and bn are 0 for n even. So we need to find which terms are being going to 0. So first condition is x of t equal to minus x of minus t. This implies that x of t is odd. So if you actually substitute this, we already found that the cos term is going to disappear. So cosine terms will disappear, including the DC term, right? So we'll get x of t, DC and cosine. Okay, x of t is summation n equal to 1 to infinity bn sin n omega naught t. Now let us use the second condition. X of t is equal to minus x of t minus pi by omega naught. So what happens to n sin of n omega naught into t minus pi by omega naught? So this is nothing but sin of n omega naught t minus n pi. Okay. So for n even, this is equal to sin of n omega naught t itself, right? Because it is periodic with period 2 pi. If n is even, then this will become some 2n pi kind of thing. And it will be equal to sin n omega naught t. For n odd, what happens? This is going to be equal to minus sin n omega naught t, because there is a factor of pi difference. So if it is in the first quadrant, sin is positive, and it will be pushed to the third quadrant where sin is negative. So it will become negative. So now what happens? So in this case, x of t is equal to minus of this. Okay, so let us substitute them. bn sin n omega naught t is equal to minus summation n equal to 1 to infinity bn sin of n omega naught t minus n pi. Right? Let's substitute n equal to some 1, 3, 5 odd numbers. Let's observe what happens. And n equal to 2, 4, 6 even numbers, what happen? So n equal to 1, 3, 5, what happens? Summation n equal to 1, 3, 5 and so on up to infinity. We have bn sin n omega naught t is equal to minus, and this is also minus for odd n, right? So minus minus will become plus. So summation n equal to 1, 3, 5 up to infinity bn sin n omega naught t. So this is not going to be changed. Both sides are equal, which is what? Which is nothing. We don't get any extra information, right? Let's check what happens for n equal to even. Summation n equal to 2, 4, 6 and so on up to infinity bn sin n omega naught t. And this side we'll get plus from the sign and minus here. So we'll get minus summation n equal to 2, 4, 6 to infinity bn sin n omega naught t. So now if we take this to this side, we'll get 2 times of this term is equal to 0. And if we divide by 2, we actually get the even terms to also go to 0. So even sign terms also disappear. So what is the question? So ANs are going to be 0 for all n. So this is correct, right? So these both are wrong. And what about Bn? Bn is going to be 0 for even n's, correct? So Bn is 0 for even n. So the correct option is option A. So that's all with this video. I would urge you to go back and solve more questions on this topic. Until I see you next time, it's bye from me. Take care.